Hello guys, welcome back. So in this video we are going to see the graph representation using adjacency list. So in the last video we have already seen the graph representation using the adjacency matrix, right? So as we know, we can represent the graph, we can build the graph using two approaches. Either we adjacency matrix we will use or adjacency list. So let me clean this some part of the code, right? We do not need to worry about the main method and the printing the graph, right? Because see, the logic for printing the graph is will remain same and building the graph will remain same. Only the approach that we are building right here, the coding, right, that we have to see. But printing the graph, I don't think there is any change. But let's go and see there is any change, then we can see together. Okay, so let's start graph representation using adjacency list. So here we will remove the matrix and we'll say we are going to see using the list, adjacency list. Okay, so now we will remove this you can say array, and we will say this is not array but this is your linked list, right? So I'll create a list, linked list, I'll say linked list, and this linked list will contain generic things like integer data, integer primitive data we will keep like that. Okay, integer object, and then we can save. Okay, so we have to import the linked list here. So I'll use java.util method, java.util package will use, and then we have our linked list is ready. Okay, so now adjacency we will update this name. Now this is not adjacency matrix but this is your adjacency list, right? So I'll say adjacency list. Okay, now I will update this adjacency list everywhere that we have used, and here I will remove these things and I will say I will use what new keyword and will use linked list object, right? So linked list I will say, linked list I will say, and I will close it, right? So now we know that we are giving the default value here, right? Only integer by default value will come. But if we will pass the element here, right, if we will pass the element here in the adjacency list, then we will have the data. Okay, so let me write here, I can write here number of vertices. If I'll write the number of vertices, then I think we have to remove from these things we have to remove. What happened? I didn't manage things. Number of vertices is there. Now we have updated number of vertices, and linked list we have done. I don't think we require the size, right? I don't think we require the size, but okay, think like this. See what we have done. We have implemented the linked list here, but we have not added why we are not able to add here on the list, because see here we have only defined the linked list, but we have to take a like a 2D array we are using, right? So we have to use like a array. We cannot keep like this. So we have to, now we can write its size, right? Either you will write a you can say box, and then you can provide here the number of vertices, right? And we can remove these things. Okay, you can see, right? Let me zoom a little bit. So what I was saying, because adjacency matrix we were taking what 2D array, right? So that is why we will take a list, linked list. This is your object linked list, and it's a array, right? So it will keep the list will contain its all the neighbors, and so we have to take a array of linked list, right? And so to initialize this adjacency list, we have to write like this, new linked list, and then we will pass number of vertices, right? And then we'll keep adding all the adjacency elements on the matrix. Yeah, right? So we have taken number of vertices here, and that we want to add here. I don't think much changes is there. So on the when we have the add list is there, so what we will do, so it's very easy actually. One more thing we should do, because we have not initialized all the things here, right? we have only initialized the adjacency list but not the array elements, right? You can say. So all the index we should also initialize, right? Because we cannot do like this here. If you do there, it will give you error, right? So for that we can create here a for loop here, and we'll go for all the vertices. So I'll start with int I equal to 0. I should be less than number of vertices, right? And then I plus plus, we can say, like this. Okay, then I'll go with the adjacency list we have. We'll do at some I at index, you can say, and here we have to initialize a default linked list, you can say, like this. So you can add the adjacency list at I dot we can do, and we can add the element in here when we will do that. So now I can take this one, or you can say here, or we can put here like this, right? And we can remove one of the elements from here, right? Like what I am trying to say, like this we can do. And then you can add vertices here. So what is the vertices? And vertices. What happened? Elements are there, so you can add and vertices. I think it should work, right? So adjacency list is there. At start and at start vertices we have done, and then add. Let me remove and then I'll try again. Why is the error coming? I have to see. Let's suppose I have initialized this already, right? If I have already initialized this, then what should I do? At I will use these vertices, right? I will use these vertices. Then at this I will do add. Once I will do add, and I can provide what? And vertices and vertex. We will close this here. I don't know what was the problem, but same thing we have done, right? Similarly, this can be undirected graph, so we can add these vertex here and vertices, and a start vertex will go here, means vice versa. And why we are doing, you can say, for undirected graph, right? For undirected graph we are doing. Okay, and rest of the thing will keep like that we have already seen. I hope you understand. I am getting some error. Okay, yeah. So at printing the graph, what we have to do, just we have to print from the you can say the given vertex, right? So how we will get these vertices? So first we have made already the for loop, right? We will go with all the for loop. Then what we can do, we can print here. You can print your vertex if you want to print, or we can keep moving for all the vertices. So I'll create one vertices outside here, means I will add the vertex here. So to add the vertices, what we have to do, we can create all the we are going with this value, right? So I'll say nothing but vertex. I will say vertex, and this is we can make a plus symbol, and we'll say I, and then plus space. So we can say vertex, which vertex we are talking about, and we can print the value. Similarly at each vertices, right, we will have the elements. So this for loop we have to implement, we have to remove, and we'll say this is nothing but your vertex we are talking about, and we can get the vertex from where? From the adjacency list, right? So the for loop you know, right? What we will do, adjacency list, adjacency list dot not dot at, you can write at I. We'll get all the elements, and so we will add here another vertex, and we'll say the vertex element is, we are talking about which vertex element? right? So we'll get all the vertex at a time, right? So remove this because I have taken vertex, so I am removing this part, and I'll keep one space here, and then we'll go for one more single line. So what I'm doing actually, after this I'll take a line, then you will understand. I'll go with the all the nodes, you can say vertex. So one vertex will print which vertex we are talking about. For vertex I, there will be one vertex. Let's suppose therefore one vertex here, what we will have, will have some vertex name. So I like vertex 0, vertex 1, 2, 3, like that. At each vertex, how many adjacency are there, that we can see here, all the vertices. Okay, and then we will print the elements. I hope there is no any error. Let me check what is it is talking about. Yeah, that's all. Let me zoom out and see one more time. So we have taken adjacency list, we have taken, yeah, and then number vertices. I hope this should run. Yeah, you can see, right? For vertex 0, what we have added here, right? Here you can see, right? 0 is adding 1 and 4, vertex 1 is adding 0, 1, 2, vertex 2 adding 1, 1, 3, and like this, that we can see here, right? And vertex 3 is adding 4. So those things are there. Okay, I hope you enjoy this video. If you like this video, please hit subscribe and put me the comment that I will continue the similar way that I'm writing line of line the code, and I'm help you to understand the graph algorithms and the graph based problems that you can implement in the product based company. And if you really like this video, please hit subscribe this channel, and I will keep uploading the video. Please also suggest if you want new topics. I'll go through that. Thank you guys, thank you for watching this video.
Thank you guys, thank you for watching this video, and if you really like this video, please subscribe this channel.